The moon is like a museum of 4.5 billion years of solar system history, and ESA is determined to play a role in exploring that museum. It's nearly 50 years since the first moon landing, something that I remember from my childhood. And you might ask, why do we need to go back to the moon? Well, when the Apollo moon landings happened, they only went to the equatorial regions of our 8th continent. They barely scratched the surface of understanding what the moon can tell us about the history of the solar system and its potential to support future exploration. So it's time to go back. We know a lot more now about there being potentially water on the surface of the moon, and that is both scientifically interesting for what it tells us about the distribution of water and the origins of life, but on the other side, it's potentially material that could support future explorers to go further, to learn to live off the land, and sustainable exploration is the big goal for the 21st century. 50 years ago, it was the United States acting alone. Now, everything is done in international collaboration in one way or another, and that's a vital part of the vision and the benefits of space exploration is this international partnership. But even more so now, we have the opportunity to engage industrial actors and private sector players in a different way. So it's a more complex but more exciting world of space exploration now. So there are 4 different projects where ESA is already or might in the future get involved in lunar exploration. They're going to tackle different challenges and take us stepwise forward into our exploration of the moon. Now the first, and really significant, is a collaboration working with the Russian space agency Roscosmos on a project called Lunar Resource Lander, or Luna 27. And this will be the first European hardware to go to the surface of the moon, and we're going to have a vital role with our Russian partner by providing the precision guidance system, the navigation system to avoid the wrong craters and land in the right place or in the south polar regions of the moon. And then once we've got to the surface of the moon, why are we there? We're interested to try and take a sample of the permafrost, the frozen regolith and ice that we believe are in these regions, take a sample with a drill, bring them up to some instruments aboard the spacecraft. So our pilot system will get us down to the surface of the moon, and our prospect system will take those samples up and analyze them in a mass spectrometer, work out whether there is water there and a little bit about the history of that water. Now, the second project is also very exciting, where we're already deeply involved in a cooperation with our US colleagues, NASA. NASA is working on a project called Orion, the new human spacecraft, which will be able to take 4 astronauts on missions into the solar system. And for this spacecraft, Europe is providing the service modules, so that's providing the power, the propulsion, the water, the oxygen, all of the supplies needed by the explorers. And so the first of these service modules is already being built, and for the first mission, which will be launched on the first flight of NASA's giant new Space Launch System, the SLS rocket. The second of the service modules will be the first with astronauts aboard, and that will go on a mission round the moon in the early 2020s and will be taking us back into deep space for the first time since the days of Apollo. Now, where is Orion going to go to? Well, one of the possibilities is to build a kind of mini space station or spacecraft in orbit around the moon. We call this the Deep Space Gateway because it's designed to teach us how astronauts can live and work 1,000 times further out in deep space than we are aboard the space station. And they'll give us the possibility to do science experiments in the lunar orbit and maybe control robots down on the surface of the moon. So one of the ways that might create this human-robotic interaction is the mission concept that we like to call Heracles. So it's the idea of sending a relatively sophisticated lander and a rover to the south polar regions of the moon, a rover that will be capable of acquiring samples from some of the unexplored regions that we think are scientifically exciting, and also to reveal whether those samples have the potential to support future human exploration by living off the land. Now, the idea is those samples will be brought back to the lander vehicle, which would have an ascent craft bolted to the top of it. That would take off, go back into lunar orbit, and rendezvous with the Deep Space Gateway. So the whole mission would be operated by the astronauts aboard the Gateway, and the samples would come back to them and then be returned to Earth on the next Orion spacecraft going back to the home planet. This mission has come out of discussions with our colleagues in the Japanese Space Agency and the Canadian Space Agency, and together we hope we will make this mission happen in the 2020s. Now, we've talked about living off the land as being one of the dreams and hopes for space exploration to help make it more sustainable. But although the theory of doing so-called in-situ resource utilisation has been talked about for a long time, nobody's actually demonstrated it on the surface of the Moon. But to get our payload to the surface of the Moon, we want to challenge the industrial community and say, well, maybe we, ESA, don't want to build a spacecraft, we just want to buy a transportation service. Can you get us to the surface of the Moon? And so this idea of a commercial partnership to deliver new science and technology and exploration, we see as one way forward to deliver more outcomes, more benefits in a more cost-effective way than before. So this is a really exciting scientific and technological challenge, but also a challenge for the way we do exploration in the future. We have a solid plan now with the Lunar Resource Lander as the first step, and a vision to go forward with all of these different mission concepts. That will, in the end, open the door for European astronauts to take the first steps onto the lunar surface sometime perhaps in the 2030s. And this great vision for exploration is based on international partnership and partnerships with our commercial and industrial organisations here in Europe. It's a great vision for Europe, and I hope everybody will see its great potential for our future of space exploration.